Let's now introduce the topic of interval estimation. For the y variable. Alright, and before we do that, let's just give you a quick view of the point estimation for the y. Alright, the point estimation, you can do it several ways, but one is graphically. Okay, you can have your estimated line, and what the question is, what if x is this value? Then what will y be? So what we'll do essentially is to go up to the line. It's supposed to be straight up, and then across to the y-axis, and this then will be the estimate of y. Right? The other way of doing it is to get your particular estimated regression line, right, and insert the particular value for 0, and then calculate the point estimate for y. The only trouble with that, of course, is we have no idea how certain we are about that estimate. Would our interval estimate be could it be from here to here, or from here to here, etc. So what we really need is an interval estimate. Right. The trouble with the interval estimation is there are two types, and they are very similar in concept. The first one, since we know the name already, is called a confidence interval. Which I will use CI to abbreviate. And the other one is the prediction interval. Which I'll use PI to abbreviate. Alright, let's discuss both of those and try to point out the differences. The confidence interval is an interval estimate of the average or expected value of y given x Another way of saying this is that the confidence interval attempts to capture the true line the true or population line. The prediction interval is an estimate of an actual or observable that's the prediction interval, PI, attempts to capture actual points. Actual values, and not just the line. Alright, so we'll abbreviate that in general to say that the confidence interval is trying to estimate the expected value of y given x, and a prediction interval is just trying to estimate y given x. Remember that both of them are estimates. So an estimate of the expected value of y given x and an estimate of the actual value of y given x. Alright, now let's write out the formulas. For both formulas, and we've written it down before, we'll need the point estimate. We get that by substituting the value of x into the estimated regression. And then for the confidence interval, we use that value as the midpoint, the y-hat, plus or minus an appropriate t-value, n minus 2 degrees of freedom, half of alpha in each tail, times s of e, the standard deviation of the errors, times the square root of 1 over n plus x minus x bar squared divided by the sum squares of x and the prediction interval looks very similar. It's only one added term here, so it's y hat plus or minus again the t value, n minus 2 degrees of freedom, half of alpha in each tail, times s of e times the square root of 1 plus 1 on n plus x minus x bar squared divided by sum squares of x. Alright, so the only difference between those two formulas is the 1 in the prediction interval. Alright, also note that the x that is given in the problem, either a confidence interval or prediction interval, is the same x that goes into the estimation of the point estimate, and here under the square root sign is the same value of x. Okay. To give you an idea of what these confidence intervals and prediction intervals look like, let's go to this diagram here. The red lines here will be the 95%, for instance, confidence intervals around the estimated regression line. The blue lines in this diagram, the outer lines, are the 95% prediction intervals. So you can see here that the points, the prediction intervals are narrowest at a particular point, and then they get larger and larger as you get further away. And the same thing happens to the prediction interval, even though it's not so pronounced. Both the confidence and prediction intervals will be the narrowest at x bar, which means that the closer you are to the average level of experience for the x, the better your estimates will be. The further away that you are from your average level of experience on x, out here for instance, the worse your estimates will be. And that hopefully makes sense. Alright, so now we're ready to look at an example of this.